All right. Anybody in here go to the hackathon over the weekend? Oh, I'll have to find out from. Apparently, I think it was a 36-hour hackathon. Is that right? I talked to them somewhere in the middle. They seem to still be in good spirits. We'll see how it went in the end. I haven't heard the results.
Did they actually finish a project?
I don't know. I'll see most of them that were there in my 450 class this afternoon, so I should get the feedback. I just thought there might have been a couple people. Shut up! The number of white belts just keep diminishing as the class goes on. I think we're going to make the belts a requirement for the free soda when we get our new stock in. We have had the discussion with esports to not take all the soda. You have to be a CS major to get free soda from our soda machine. No, it'll be fine. Or athletics will help us pay for the soda. One way or another, it'll work out fine.
Well, where's the shipping at? Like, I'm dying in there.
What's this?
Where's the new shipment of soda?
Oh, when's the new shipment of soda coming? Well, I actually thought it was going to be here Friday, so I assume today. Sometimes the mailroom holds it hostage because we order like 30 cases of soda and they don't really want to deliver it up to here. Well, that's okay. I don't want them to. Just tell us and we'll come down and get the pallet. But sometimes there's a little bit of animosity there. But what's your soda of choice? Pepsi?
Nah, it's gotta be. Like
You go to the cafeteria for Pepsi.
It's gotta be like a sugary thing. It's gotta be like playing games. Something don't do.
We're usually the only place on campus you can get Coke unofficially. Yeah, because we're a Pepsi campus. There's like contracts and stuff, so that's on the down low and on recording. That's on the down low and recorded. Yeah, I think we're the only place you can get. Well, actually, you can't get Coke right now. You can't get. I think there's cherry Coke in the machine right now.
It was regular Coke. It was like regular Coke.
When there was regular Coke in there, but I mean, in terms of what's currently in the machine, I think there's like a couple of cans of cherry Coke still in there. All right. Yeah. So in any case, let's look at the homework. How did that go? So this should be a good one from looking at some helper functions for things. So homework was this table printer one. All right. So you're taking in a shut up. You're taking in a list of lists where you have a variable called like table data, whatever, and this guy is going to, in our example here, we have 3 lists. Each list has the same number of elements in it. But we're going to have to write a function initially that's going to go through a list of elements, finding out how long the longest element is. Because we need to use that when we're displaying things in a particular column. So notice that here with apples, so we have apples, oranges, cherries, banana. The width of that column is based off of the longest string in there, which is cherries. Alice, Bob, Carol, David, that's the second one. The width of that column is based off of the longest string inside of that. So we're gonna break this down into some smaller pieces. All right, so let me actually, since we already have this code pasted up somewhere, let's just dump this for now and we'll keep going. All right, so I'm going to give myself a starting point. I also mentioned last time that I was going to force Python into a situation that it acts more like modern programming languages. So I'm going to define a function here called main. All right, and inside here I'll say a is equal to 5. I'll print out a. Now up here I'll say def. We'll go ahead and we're going to start writing our new function. I'll just do it in terms of this. So we'll call this guy length of longest string. And this guy will take in a list as a parameter, and his job will be to take in the length, to print the length of the longest string. And I'll go ahead, or to return the length of the longest string. But I'm going to go ahead and print a variable called a in here. If you remember from our notes last class, we have this global scope, the stuff that's in the yellow here. And in that global scope, any variables that we define, so for instance, out here in the global scope, if I say b is equal to 7, I will be able to print out b in here. I'll also be able to print out b in here, because this guy is part of that global scope. All right, this variable b is available anywhere in our program. Okay, so what I'm going to do here, so let's just prove that here real quick. So if I go ahead and I call main, and then I call length of longest string, and this guy expects me to pass it a list. I'll just pass it an empty list right now. Notice that it tells me that up here, this variable a is not defined. It does not know about that variable a, because where was a defined? It was defined inside of main. So its scope lived and died with main there. That is to say that anything we define inside of this red box is not available inside of this red box. These are two completely separate variable scopes. All right? But if I don't print out a here, now we see that this guy works, because this guy knows about b because b was part of the global scope. Main knows about a and b. It knows about a because it has a local variable here called a, and then it has a global variable called b that it has access to. See how that works? So in order to force this agenda, we're going to go ahead and remove the idea of a global scope from our program. All right? So we're going to have something, I'm going to say if underscore underscore name underscore underscore is equal to then I'll just call main like that. Oh, yeah, I took out the global variable b. So no longer do I have a variable named b in either of these. So I can, I'll just print a 7 there for a second just to see this working. All right, so now this line right here is what my global program does. So my program, the statement I would usually make in programming classes is for main, I maybe even already have a slide that says this, all programs begin and end with main. And you will find that to be a truth of any C-based programming language. So what I've done here is I've hijacked my local scope, my global scope rather. I actually didn't even need to write this line if I didn't want to. I could just randomly put main down here in the bottom. But there is a local variable. There's something called name, like where am I currently, and it's called underscore underscore main. So that does automatically get called by the Python interpreter. And all I'm doing in there is I'm calling the function I'm writing called main. So what we're going to do is we're going to start writing our programs inside of main, and that's the guy that will call all the other functions. This will force us to be working with a local scope of main, a local scope of length of longest string, so on and so forth. All right. It will take away that behavior of us having these variables that accidentally work inside of other functions because they happen to be part of the yellow box that all of these guys have access to. Now main is like this red box, and all my other functions are these other red boxes, and those guys do not have access to variables that are inside of other red boxes. Okay? So we're forcing the scoping rules. Yeah.
Could you use like the same letter in like different boxes to define like different variables?
Perfect question, yeah. So for instance, I could come up here And I can say A is equal to 13. And I can print out A here, and that's perfectly legal. All right, it's perfectly legal because, and actually let's, I'm never actually calling length of longest string here. So in main, I'll define a variable named A, set it equal to 5. I'll print out A. A variable resolves to its most local definition, so A boils down to its value, which is 5. Then I'll go ahead and call length of longest string, passing it an empty list for right now because I'm not doing anything with this variable. He will define a brand new variable in his scope called A, set it equal to 13, and then print out its value, which will be 13. So I should get a 5 from this one and a 13 from this one. Same variable name, living in two separate scopes. Those are two completely separate variables. And as soon as this guy ends, if I come back and I print out A again, A is back to its original value of 5. This variable right here has lived and died with that scope. So now we're back to the 5. Yeah.
Why would you, in line 16, why would we use the if statement to run the main function? Why not just type in main?
It's more of a Python thing. I can just randomly throw main down here, but there's actually some, there's this global variable called name that says which subsection am I in, for maybe lack of a better phrase, and there's a default subsection called main. So
Does that make it work better?
probably not in terms of an interpreter. Interpreters are already inherently slow. I guess I would say this maybe makes it look cleaner than just randomly having a call to main sitting out there in my program. Something like that. There's probably not unless you were using one of the other global name labels, this is not necessarily required. So for us right now, we're just going to say we're going to always write it like that, and we'll put what used to be in our global scope inside of this main method, which gives us a scope associated with main. And that behavior is identical to how most modern languages work. Most modern languages, if you write a Java program, for instance, you create a main method. And that main method has its own local scope. Yeah?
So the if statement, if name equals main, will that always be true? Will that always run?
Yeah, it will. Yeah. For us right now. Because there are some other things that this variable could equal that are not related to anything we're going to do. So for us right now, it will always be true. Which, to his point, means if this is always true, do I even need it? The answer is no, but I think it does give us a little structure in our program that's kind of saying, I'm only calling main when I'm supposed to call main, which for us is always right now. Okay? Questions about those scoping rules? So from this point forward, let's write all of our programs in this kind of structure. That way we don't have those issues with those global variables. I think that'll help you not have functions that accidentally work because you have access to global variables. I think that's one of the challenges was for folks having a misunderstanding how variables were passed. All right, so this length of longest list. So I'm going to go ahead and inside main here, I'm going to give myself a list. So I'm going to say, what are they called over here? We'll call it table data, apples, oranges, cherries, banana. So we have table data, and this guy is going to be equal to a list. And this list is going to contain 3 things. The 3 things it's going to contain are 3 lists. And if you want to put these down on different lines, you can. I believe that'll work fine. All right, so there's my table data. Now I'm going to go ahead and fill this guy in with stuff. So apples, oranges, cherries, banana. Apples, oranges, cherries. Is it bananas? Or banana and apples. Okay. All right, so that's the first thing in my list of lists. The next thing is Alice, Bob, Carol, David. Alice, Bob, Carol, David. That's my second list. Last one is dogs, cats, moose, goose. All right, and let me just make sure that that format of putting it on separate lines is okay. I believe it is. Yep, okay. So I created a variable called table data. I set it equal to a list containing 3 elements. The first element is a list, the second element is a list, the third element is a list. And the rules of this question indicate that those lists must all have the same number of elements in them. In this case, that number of elements is 4. There are 4 strings per interior list. All right. Now, we can prove that. We can loop through this list if we're just kind of exercising, practicing our skills that we've worked with here. We can say for L in table data, print out the length of L. And that should give me 3/4. So this for loop goes through every element inside of table data. So the first time through, L will be this first list. The length of L is 4. The second time through, L will be this list, which has a length of 4. The third time through, L will be this list, which has a length of 4. That's what my 3/4 are right there. All right. Now, what we want to do is we want to pass each of those lists to length of longest string. We want to be able to, given a list, return that the longest string inside of this guy is what, 3, 4, 5, 6, 7, 8? We want it to return an 8 for this particular list. The longest string I found inside of that list was of size 8. Make sense? All right. So inside of this function, I want to write a loop that's going to go through every single element of whatever a list is. You do not have access to a variable called table data in here. The variable you have access to is called a list. So I'm going to go through, I'm going to say for, we'll call it L again. Actually, we'll call it S for a string. For string in a list, we'll print out the length of S. So I'll go ahead and actually, let's go back here. We will call length of longest string on each of those sublists. So here in main, I'm going to go through each one of these lists and pass it to length of longest string. So the first time through, a list will be equal to the apples, oranges, cherries list. The next time through, a list will be equal to Alice, Bob, Carol. Next one would be dog, cats, moose. All right. So, and what does length of longest string do? It goes through every string in whatever list you passed it, and it prints out the length of that string currently. So there's that 8, the length of cherries. All right. But really what we want this function to ultimately do is we want it to return the number of characters in the longest string in that list. So maybe when this thing first starts, the longest string, maybe we start off at -1. Are we guaranteed that the very first string is going to be longer than -1? Yeah, it'll be longer than -1. All right, so we'll give ourselves a starting value of -1, knowing that the very first time through, we're going to be replacing it. Now we're going to ask a question. We're going to say, if the length of S is greater than longest length. If that's a true statement, if the length of the string I'm currently looking at is longer than my current longest string, I'll go ahead and set longest length equal to the length of S. But only if I found a longer string than I had previously found. Once I've looped through all of my strings, longest length should hold the longest value, right? Go ahead.
You want it in the longest value of all 12 words, or is it for each list within the list?
Well, let's answer it two different ways. From the perspective of this function right here, this guy is going to return the longest string in whatever list you give it. That's what this guy does. If we look at the question here, we need to know for each of these columns what the longest string was so that we can set the right width for that column. So the larger problem we're solving means that we need to know what the longest string is for each of the lists. This function we're writing right here, his purpose is for me to pass him a single list of strings, and he will return for me the length of the longest string in that list. That's what that tool does. And now I'm going to use that over here. Okay? So what I'm actually going to do is I'm going to say, let's create another table maybe called string lengths. And what I'll do here is I'll say string lengths dot append whatever's returned by length of longest string for each of those lists. So I should get an 8, then what is this one, a 5, then a 5, 855. So I'll go ahead and print string lengths. And there's my 855. This for loop, what made L, the first time through L was this list. I passed that list to length of longest string. It went through and found that the longest string in there was 8. And I appended that to my empty list called string lengths. Next time through, it passed this list in, and it found that the longest string in there actually was Alice, because none of these other ones were longer. We had a tie, right? A couple ties, but nothing was longer than Alice, so it returned a 5. And we appended that to string lengths. So now string lengths has an 8 and a 5 in it. Then the last time through, L is equal to this guy. We passed it through, and it found that the longest string was moose, right? Of length 5, because goose is not longer, it's tied. All right, so we got a 5 out of that guy, and we appended that onto it. So that's why our string lengths is now filled up with 855, the longest string in each of those guys. Make sense? All right, so I built myself a tool that I can pass a list to, and it will tell me what the longest string in that list is, or how long the longest string in that list is. I don't care what the string is, I just want to know how long it is, because I'm going to use that for creating the correct width. All right. Now, they want us to write a function named print table that takes a list of strings, takes a list of lists of strings, and displays it in a well-organized table with each column right justified. Assume that all the inner lists will contain the same number of strings like we just looked at. So we want to right justify these. So apple, oranges, cherries, banana are all right justified. Alice, Bob, Carol, David are all right justified, so on and so forth. If we scroll up here a little bit, we get to our justification things that are up here that also take in an amount of padding. Okay, so here's like the right justified, and then we get a size of 10. So for instance, if I were right justifying a value, hello only has 5 elements in it, but when I pass this guy a 10, it will give me 10 spaces and fill the far right 5 of those with hello. All right, that's what will go in there. It'll create that space for me. So I want to go through and I want to build a string that is going to be my first row. And my first row is going to be the first element of each of my 3 lists, right justified to the longest string, the longest length of the strings in each of those columns. So what was the name of the function it wanted us to do? Table print, something like that. I don't want to scroll back down, lose it. So we'll define, what's it called? Table print. And this guy will take in a list of lists. All right. So the first thing I want to do, so I'm going to kind of steal this code right here so I can calculate that stuff. So I'll go ahead and get my string lengths, and I'll fill up my string lengths with all of the correct widths for my columns. All right, now what I want to do is I want to create a string for each of these guys. That will have the right width, followed by the next thing with the right width, followed by the next thing with the right width, glue all those together, print that out. All right, my right widths are all inside of string lengths down here. My list of lists have all of my individual lists in them. So what I want to do is I want to go through each of those lists, and I want to print out the first element of each of my 3 lists, right justified to the I want to print out the first element of each of my 3 lists, right justified to the same width as the longest element in that list. So if I go back to this guy down here, I'm going to print out apples right justified on 8, concatenated with Alice right justified on 5, followed by dogs right justified on 5, because that was the longest thing in that list. So I'm going to build up a string, display that string. All right. So I'm going to be building a string inside of a variable. Start off maybe as the an empty string. And I want to go through, in order to get apples, Alice, and dog, apples, Alice, dog, those come from bucket 0 of each of the elements in this list. So the length of this list. This is bucket 0, this is bucket 1, this is bucket 2, this is bucket 0, this is bucket 1, this is bucket 2, this is bucket 3. All right, so we have 4 rows, which is the length of the first table. So I want to do something 4 times. So 4 times I want to build strings. Now they've promised us that print table, this list of lists, each list in here has the same number of elements in it. So I know they have 4 elements in it. All right, so if I want to throw that in a variable, I can go ahead and say length of inner list is equal to the length of list of lists at bucket 0. And this should be 4 by our example, right? So if I go to the very first element in my list of lists and I ask what's the length of that guy, the length of this list right here is 4. If I go to the second element, it's also 4. If I go to the third element, it's also 4, because they've promised us for this assignment that all of the things will have the same length. So I'm going to go ahead and just store in a variable here, called length of inner list, the length of the very first list. That's how many rows I'm going to be printing. That's how many things I'm going to be doing. All right. So I want to repeat this for the number of rows. So I'm going to say for row in range 0 to length of inner list. That'll go through there that many times. Now for each row, what do I want to do? I want to build a string. I want to build a string that has the first element, well, the first time through, that has bucket 0 of this one right justified to the correct number of spaces, bucket 0 of this one right justified to the correct number of spaces, bucket 0 of this guy right justified to the correct number of spaces. And I just happen to have inside of string lengths, bucket 0 of that guy has the correct number of spaces that this guy should be right justified to. Bucket 1 of string lengths has the correct number of spaces that this guy should be right justified to. Bucket 1, or bucket 0 of, bucket 1 of, 0, 1, bucket 2 of string lengths has the correct number of spaces that that guy should be right justified to. And I want to build that string because I want to print these one row at a time. So I'll say S is equal to the empty string. We're going to be building up a string off the empty string. All right, now I want to go through every element of list of lists, every one of those lists. So for L in list of lists, I want to do something. What do I want to do? I want to build a string. What string am I building? Well, I'm going to take my current list that I'm looking at bucket row. So if I'm looking at this list right here, for example, and I'm currently doing row 0, I'm looking at apples. I want to right justify apples on 8, which happens to be bucket 0 of my list of my string lengths. All right. Now, I actually need to know which index I'm currently at in here. So when I go through each of my lists and I say, give me my list at a certain bucket, that's for my 4 things. Let's go back here and look at this. So I'm going through every single list in here, and I'm building a row out of bucket 0, bucket 0, bucket 0. That's what makes up my first row. And the right justification of those guys have to do with bucket 0, bucket 1, bucket 2 of all the things in my string list, string lengths that had 8, 5, 5 in it. So I should have apples right justified by 8, Alice right justified by 5, dogs right justified by 5. That make sense? All right. So that's what I want to print out. Now we could do this a couple different ways. We can build up strings, or we can go through and we can replace all of the strings inside of our list with their right justified version of themselves. Okay, you can decide which one makes more sense for you. We're ultimately going to be doing the same logic. All right. So I'm doing something 4 times. What am I doing 4 times? I'm building a string. What string am I building? I'm taking bucket 0 for my first one, bucket 0 for my second one, bucket 0 for my third one, because I'm currently on row 0. That make sense? But I need to know, for these 3 guys, I need to know how many things were in this guy for each of these lists. I was working with list 0 I was working with list 0, bucket 0, list 1, bucket 0, list 2, bucket 0. I needed access to that element 0 from that. This guy right here, L, this is taking me through each of my 3 lists. And I'm working on a particular row, but I actually need to know the index of this list. I need to know what I'm working with so that I can get the correct value for that particular guy. What do I mean by that? L was this the first time. L was this the second time. L was this the third time. If I'm currently working with this guy L, and I'm working with row 0, this is the string I'm interested in. How far does he need to be right justified? He needs to be right justified at whatever bucket 0 was of my string lengths. If I'm at this guy, and I'm looking at row 0, I'm working with bucket 0 of this guy. What does he need to be right justified at? I need him to be right justified at bucket 1 from my string lengths. Bucket 1 of my string lengths indicates which of these lists am I currently going through. I'm currently calling this guy L, then L, then L, instead of the list at bucket 0, the list at bucket 1, the list at bucket 2. So that list of bucket 0, list at bucket 1, list at bucket 2 references the indexes of my string lengths. So while this guy is convenient for going through every list inside of lists of lists, my preferred way of going through this would be this guy. For I in range 0 to length of inner list. We can say length of string lengths, or we could say length of table data or list of lists. Either one of those. Those are equal to each other. All right. So the length of list of lists in our example here, there are 3 lists in here. So the length of list of lists is 3. We also saw that the length of string lengths that we built is also 3. Those guys are synonyms with each other because this list contains the length of the longest string in the first list, the length of the longest string in the second list, the length of the longest string in the third list. All right? So it doesn't matter which of these things I say. Do I say length of list of strings or do I say length of string lengths? They're the same because those 2 lists are related to each other. All right? So I want to go through each of those things. And what do I want to do? Well, the first time through, if I'm dealing with his apples here, I want to get bucket I of, I want to get bucket row of this collection. And I'm working with bucket I of that guy. So bucket row would be the list that lives at bucket 0 of table data this time through. Because row is equal to 0, then it's 1, then it's 2, then it's up to 4. That's the number of rows I'm going to have, 4 rows. So if I'm currently working at row 0, I'm looking at this list. So I want the list that lives at row. Let's start with that. This is the list, L. Actually, it's not L. It's called list of lists, since I changed my loop. So I want my list of lists at row. And that guy will give me either this guy, or this guy, or this guy. And then I want to get the bucket within that for what I'm currently working with. Right? What's the bucket I'm currently working with on this guy? He's going to be bucket 0, which is bucket I. But now the next time through, so apples was the first one, then I want to go to Alice. I'm still dealing with bucket 0. I'm still dealing with bucket 0. How do I account for that? I need to keep track of that the first row I'm building is going to be bucket 0, bucket 0, bucket 0. The second row that I'm building is going to be bucket 1, bucket 1, bucket 1. The third row that I'm building is going to be bucket 2, bucket 2, bucket 2. But all those guys are going to be right justified to a certain length. That make sense? Now, the reason I'm dealing with 3 different counters right now is because I've chosen to store the longest element in a list inside of another list. Right here. I've created this thing called string lengths, right? And I went ahead and filled it up with the length of the longest string in a list. So if I happen to call that on this list, it'll give me an 8. And that's the list I'm currently working with, isn't it? Next time through, if I'm dealing with the next character, I'm dealing with the longest string in this guy. Then I'm dealing with the longest string in this guy. Do I have a tool that will just always give me the longest string in a list that I wrote? I have this tool here called length of longest string. And if I give this guy a list, he will give me the longest string in that list, will he not? That's what he does. All right. So I can hand him this list. He'll give me an 8. It doesn't matter how many times I give him that list. It doesn't matter how many times I use that tool. He'll always give me an 8 for that particular list, right? Now, I might say it's efficient for me to only call it once on that list and store that 8 somewhere. But can't I, whenever I need to know what the longest string in this particular list is, can't I always just say, tell me what the longest string in this list is? I could just call that tool, can't I? Rather than store it somewhere else and figure out how to reference it, you can just call upon the tool. So if I'm going through each of these rows, and for an individual row, I need to get an element at bucket 0, bucket 0, bucket 0, bucket 1, bucket 1, bucket 1, bucket 2, bucket 2, bucket 2. For each of those things, I'm going through every one of my rows. What's my governing loop? I need a loop inside of a loop. One of them is going to do some number of rows. For each row, I want to go through some number of columns. Okay, so I'm going to repeat this rows number of times. For each of those, I need to go through this number of columns. And we're going to do this with the numbers. So here's my number of rows. Each time through, I want to go through the number of columns, which is my list of lists. And I'm going to build up a string inside of there, right? So I'm currently dealing with row 0. So I'm going to be dealing with 0, 0, 0 for all of those lists. List of rows at bucket 0 each time. And I want to right justify that guy, right? I want to right justify. Sorry, I'm missing one thing here. I'm currently dealing with well, let me think about how I want to show this. Lists of lists at bucket row gives me this guy. I want a particular position in that. So I'm actually going to say lists of lists at bucket I, which will give me my list. That's my list. I want to get bucket row within that list, which will give you my string. Here's the list I'm currently looking at, and I'm currently interested in bucket 0, the row I'm working on. And what do I want to do to that guy? I want to write justify it. And how much do I write justify it? By length of longest string of what? The current list I'm looking at. That's how much I'm going to write justify it. And then what do I want to do with that? I want to concatenate it onto my running string. Once that running string is done, I can go ahead and print out that string. Loop back up, do my next row. 0 out S, go through each one of my lists, work with, now I'm on row 1 for the next time through. Row 1 has me dealing with oranges, Bob, and cats. Oranges, Bob, and cats. And I'm going to get the padding for each of those by just asking my tool to give me that padding. So I no longer need to create my collection of lengths up here, because now I'm getting that length each time through by just calling upon my tool. So we'll go ahead and call table print on our table data. What didn't I do? Did I not close my parenthesis over here? And there is my right justified table. Looks like they wanted you to put one extra space on each one. So we could have put a space in between like that. Okay, you see how that's working? All right, so we had a lot of moving parts there, right? All right, so what I want you to do is walk through this, because we're out of time now. We'll start this at the beginning next time. I promise you the next assignment is less cryptic than this one. This one really requires you to kind of follow the things. I think I told you at the end of last class, it's using this justification thing, but it's really having you kind of work with two lists kind of running at the same time. So walk through what we just did here using this data, and you'll see how those two things line up. We'll draw a picture of it in class next time. All right, but you have a solution to the problem now. So I'll go ahead and paste this into Slack. Next homework assignment is already up. It's easier than this one. Well, it's not easier, it's less tedious than this one. And I'll see everybody on Wednesday.